Hello and welcome to MRV Quantity Surveyors and Cost Consultants presentation on the use of the SANS1200G document in measuring the concrete works for civil engineering projects. Our chosen case study is on the Cengane Dam, which is located in Qumbu in the Eastern Cape. The project was part of the Upper Xolongo Regional Water Supply Scheme. The dam has an estimated capacity of 360,000 kiloliters, which supplies the surrounding rural areas with clean drinking water. Construction of the dam started in April 2012 and was completed in September 2013, with the completion certificate being awarded in July 2014, when the dam was open for use. Qumbu is in the Eastern Cape, approximately 60 kilometers north of Mthatha. The Cengane Dam is a 17-meter-high earth embankment dam with a 21-meter-wide concrete-lined spillway. The dam is split into three zones, namely a central core, an upstream, and a downstream zone. There is a 600-millimeter-wide vertical chimney drain, which serves as internal drainage with a collector drain at the base of the dam. The outlet works of the dam comprise of an intake tower, service duct, outlet pipes, pressure control valves, and an outlet manhole. The material use will be explained further under the scope of the works. The client for this project was OR Tambo District Municipality, with the contractor being Norland Construction and subcontractors Ezel Franke, East Coast Blasting, and Zoila Construction. The project engineer was HHO Infrastructure Engineers. For this presentation, we will be looking at the works done by contractor Norland Construction and subcontractor Ezel Franke, as they were involved in the concrete works. The general scope of the works were broken down into 7 stages, mainly the river diversion, the foundation preparation, the grouting, the earth embankment, the outlet works, the spillway, and the filter drain. As highlighted, foundation preparation, grouting, outlet works, and spillway were the stages that involved concrete works, and those are the stages that we will be looking at in this presentation. We will now take a brief overlook of the SANS1200G document. Formwork is measured under 8.2 and includes the classification of finishes, preparation of formwork reuse, and angle of support, as well as any information regarding openings or circular work. Required in the formwork description is the classification of finishes and the accuracy of formwork, the angle of formwork such as sloping, battered, or vertical, and the concrete element to which the formwork will be placed. Next is reinforcement, which is measured under clause 8.3. A guideline on bending, fixing, concrete cover, splicing, jointing, and protection of exposed steel bars is outlined in the document. There is a distinction between 3 types of reinforcement, namely steel bars, high tensile welded mesh, and rails or other steel section used as reinforcement. Then concrete, which is measured under clause 8.4. There are 6 measurable items which are distinguished: prescribed concrete mix, blinding layer, strength concrete with grade, unformed surface finishes, aggregate, and cement. Here is a list of the different items that we have evaluated in terms of the SANS1200G document, namely the formwork, reinforcement, and concrete, as well as joints and grouting, which is also prescribed in the document. We are now going to go through each of the different schedules and see how the measurement items have been used. The first schedule is the intake tower base, then we'll go through the intake tower, the bridge pier, the spillway lining, the retaining wall, the grout cap, and finally the pipe encasement. In the evaluation of Schedule 1, we found that formwork and reinforcement were measured in accordance with SANS1200G. However, the description of blinding should not include the thickness of blinding when measured in meters cubed, as we found in the schedule. When evaluating Schedule 2, we found that the testing of joints was measured separately as a lump sum. According to SANS, the rate of joints should include the cost of the material, the labor, and the testing. With Schedule 3, we found the formwork and reinforcement to be measured in accordance with SANS1200G. However, the type of finish to unformed surfaces has not been stated. Next, we looked at the spillway lining, and again found that formwork and reinforcement were measured in accordance with SANS1200G. However, the mesh measurement was in tons, as it is a PSG. The PSG is in reference to a project-specific specification that is designed by the engineers. The description for concrete does not state the place where the concrete is required, which is not in accordance with SANS1200G. In Schedule 5, we found the walls and bases to be measured separately. Formwork and reinforcement were again measured according to SANS. The description of blinding, however, should not include the thickness of blinding when measured in meters cubed. Schedule 6, we found that the dowels were measured under reinforcement, and that drilling and grouting of dowels is not covered in the SANS 1200G, however, has been added to the schedule. In the final schedule, Schedule 7, which is of the encasement of the pipe, the description for concrete does not state the place where the concrete is required, which is not in accordance with SANS 1200G. Here we are showing a comparison between the ASAQS standard system of measurement and the SANS civil measurement as to how they measure concrete works. As you can see, the bill order differs, with concrete first, formwork second, and reinforcement third in the standard system, and formwork first, reinforcement second, and concrete third. The civil measurement follows the process of construction, with formwork, then reinforcement, and then concrete. With the standard system, items are split into substructure and superstructure. However, as civil works generally are not of the same nature, they are measured as one structure, and there is no substructure or superstructure in civil works. In conclusion, there was some difficulty in obtaining detailed concrete specifications, as some of the items were referred to specific specifications by the engineer. The comparison of the SANS document was quite straightforward, and the assignment provided us with a greater understanding of the SANS 1200G document, and in particular on dam works. Please feel free to email any questions to our CEO, Courtney Mayer, at myrcou001@myuct.ac.za. This presentation was brought to you by MRV Quantity Surveyors.